Welcome to 5.2, Electron Arrangements in the Atoms. Hey, in the last podcast, or in the last section, 5.1, we learned that we don't know exactly where these electrons are around the nucleus. We only know the probability of finding them in given areas. They do exist at certain distances or certain energy levels, but yet we don't know exactly where they are in those energy levels. All right. So this section is describing how do we basically know where they are 90% of the time. All right. Think about it in terms of this. If the nucleus is right here, we're just going to make a little sketch off to the side here. It's positively charged. The electrons are negatively charged, so they're attracted to the nucleus. Yet when you get more electrons added to the atom, they're going to start repelling one another. So the electrons are going to be arranged, or they arrange themselves around the nucleus in such a way that they can be attracted to the nucleus, but yet they minimize the repulsions amongst themselves. All right, and that arrangement around the atom or around the nucleus is called its electron configuration. And the electrons follow three general rules. First of all, they have what's called the Aufbau principle. The Aufbau principle simply says that electrons fill orbitals of the lowest energy first. Now, of course, the lower the energy they are, the closer to the nucleus they are. And that makes sense because they are attracted to the nucleus, so they're going to go as close to the nucleus as possible. So the Aufbau principle simply says that they're going to start in the lowest energy level first, and then they're going to build outward. And in fact, that's what Aufbau means. It is German for build out or to build up. All right. Next. Well, if you take a look at this diagram, first, what this simply means, you have increasing energy. The lowest energy is the first energy level, that's here. The second energy level, which is right here, is the next lowest in energy. So here's the first energy level, here's the second energy level, here's the third energy level. That's the next lowest in energy. Then you have the fourth energy level, but you're going to notice that they're going to start overlapping a little bit. That gets a little more complex. We'll address that as we go. But the basic idea is that the electrons are going to start in the lowest energy level first, and then they are going to build outward. All right. Next, you have what's called the Pauli exclusion principle. The Pauli exclusion principle simply says that two electrons can fill an orbital. All right. Now I'm going to use arrows to designate electrons. So here's the deal. If you have one electron, it has to first go into the 1s orbital. I'm going to change the color on that just so you can see it a little better. There we go. If you get a second electron, it can still fit inside of that orbital. We're actually going to put one spinning up and one spinning down. Don't worry about why it's spinning, but just realize that that's the case. The Aufbau principle says that you have to fill the first energy level first, then you move on to the next energy level. So then you're going to fill the 2s by adding a couple of electrons to it. Next, you have to go to the 2p orbital. Now, the fact is, once you get to the 2p orbital, as you start placing electrons in it, because you have three identical p orbitals, the electrons are going to fill, or they're going to be put one in each orbital first before going back and filling the p orbitals. That's called Hund's rule. Hund's rule says basically that when you have equal orbitals, or orbitals of equal energy, when electrons fill orbitals of equal energy, one electron is placed in each orbital before pairing up. Simply meaning you're going to put one in each box or one in each orbital before you start adding the second one. Once that electron or once that orbital is filled, then you're going to move on to the next orbital and start putting electrons in there. When you get to the 3p, you're going to put one in each. All right, before pairing it up. When you get to the 4s, which is the next one, you'll put 2 in there before moving on to the 3d. Now again, don't worry about why the 4s gets filled before the 3d. Whoops, I'm actually doing this wrong. You're going to put 1 in each first. Get talking there. And then go back and put the pair in. And so on and so forth. Now all we're doing is we're simply showing you where the electrons are arranged around the atom. Alright? So if here's your nucleus, okay, the first 2 electrons are going to get placed in the 1s orbital. The next 2 electrons are going to get placed in the 2s orbital, which is spherical. It's just larger than the 1s. Then you're going to have to put electrons in the 2p's. The p orbitals are these peanut-shaped guys that look like this. You'll put 1 in there, you'll put 1 in here, and then you'll put 1 in here, and then you go back and pair them up. Alright? Once you fill up the second energy level, you got to move on to the third energy level, which means you're going to put 1 or 2 electrons in the 3s. Then you're going to have to place 1 electron in this 3p, another electron in this 3p, and another electron in this 3p before going back and pairing them up. Once that orbital is filled, you got to move on to the 4s, which is just like the 1s, 2s, and 3s, except it's larger. Okay? So then you fill the 4s. Then you fill the 3d. Then you fill the 4p. And all we're doing is we're placing electrons in these probability areas, first as close to the nucleus as possible, and then working our way further and further away from the nucleus. And again, the whole idea here is that they want to be as close to the nucleus as possible, but yet they repel one another. So you can't cram them all right next to the nucleus because they're all going to push each other away, because they're all negatively charged. So you have to put them in these probability areas that maximizes their ability to feel the nucleus, but minimizes the repulsion amongst each other. All right? Okay, in the next podcast, what we're going to do is we're going to take a look at individual elements, and we're going to show you where their electrons are placed.